like to do is we like to review chapter 16. This is coming from the review practices. Today's focus will be the line integral. So let us look at number 3 first. So they want you to evaluate this one. So how would you do it? They tell you that x and y and z are defined in this way. This will be the line that we are passing through, where t goes from 0 through pi. Then for x and z, y and z, we're gonna place these two things over there, substitute them in. And then in case of ds, we will be taking the square root of r prime, magnitude of the r prime. That's essentially what we're going to be doing. So what is r prime? That's equal to 1. And here we get -3 sine t, and next one is 3 cosine t. So magnitude of r prime, which will get us ds, is in fact equal to square root of 1 plus -3 sine t square plus 3 cosine t square. Now, then you realize that these two add up to be 9, because sine square cosine square equals 1. So this one is equal to 9 plus 1, we get square root of 10. So our integral now becomes 0 through pi. So in place of y, we have 3 cosine t. And z, we have 3 sine t. And then cosine of x, which is equal to t. And square root of 10 dt. So then when we simplify this one, we can take 9 and then square root of 10 out. Going from 0 through pi, 4, we have cosine square t sine t dt. Then of course, in this case, we can set u as cosine t. Then we know that du is equal to negative sine t dt. So what we end up getting is, because of the negative sign, we're going to pull out the -9 radical 10. And then we're going to get cosine cube t over 3 going from 0 through pi. Now, so far, this is what we have. Now, what we need to do is we're going to plug in pi and then 0. When you plug in pi, what do we end up getting? So -9 radical 10 over 3. We're going to cancel them out later. But when you plug in pi, we get -1 to the third power is still -1 minus. When you plug in 0, then cosine becomes 1. So that's what we end up getting. So our final answer now becomes negative becomes positive. So we get 6 square root of 10. That becomes our final answer. All right, let's look at number 5. Same idea. We are going from here to here, but the path is given in this way. You see, then since x is in terms of y, let's try to rewrite this one. Y cubed is y cubed, but dx now becomes negative 2y dy. And then second one is plus. X was 1 minus y squared, so we have 1 minus y squared of that square dy. Since we have dy in both places, I'm going to pull that out. So we get -2 y to the 4th power. And then here we get plus 1 minus 2y squared plus y to the 4th power dy. And then you know that y goes from -1 through 1. So that's basically what we end up getting. All right, now, but when you simplify, these two terms, we're going to get -1 through 1, negative y to the 4th power minus 2y squared plus 1 dy. Now let us try to integrate this one so that we get negative y to the 5th power over 5, and then minus 2 over 3 y to the third power plus y, negative 1 to 1. When I plug in 1, everything becomes negative 1/5 minus 2/3 and then plus 1. Minus, when you plug in negative 1, we get 1/5 and then plus 2/3 minus 1. So when you combine them together, we get 4/15. Alrighty. So that becomes our final answer. Let's look at the next one, number 7. So in this case, unlike number 5, we just know that it's a straight line. Then we need to come up with each parametric equations here. So x, I'm going to start from 1, but I have gone up by 2 units, so plus 2t. Y will be equal to starting from 0, and then plus, I went up by 4, so 4t. Z, I started with negative 1, but I went up by 3, so plus 3t. So that can be the parametric equation that represents the line segment going from here to here. Now, what we want to do is we want to find that dx, dy, dz. So dx is equal to 2 dt. dy is equal to 4 dt. And dz is equal to 3 dt. All right. So far, so good. Now, of course, t goes from 0 through 1. Now, then all we have to do now is put everything in together. Then our expression becomes x times y. So I'm going to multiply these two. 1 plus 2t times 4t. But the x contains factor of 2, so I'm going to multiply that by 2. Plus y is 4t squared. But dy has factor of 4. Plus yz, so I'm going to multiply those two. So 4t, negative 1 plus 3t. And then we're going to get factor of 3, and then we're going to get dt, which goes from 0 through 1. Now, once we came up to here, what we have to do is we need to combine them together. So you get to realize that. It's a little bit annoying, but you should be able to do it. So we have 8t's multiplied by 1, so we get 8t. And then plus 16t squared. And the next one here becomes 16t squared plus times 4. We get plus 64t squared. And the next one is the 12t is multiplied here, so minus 12t. And then plus 36t squared dt. So when you simplify this one a bit further in terms of t squared, here, that's 100, so we get 116 t squared. That's what we end up getting for the first one. Second one is minus 4t dt. Then when you integrate this one, we get 116 over 3 t to the third power, and second one is minus 2t squared, which goes from 0 through 1. When you plug in 0, everything becomes 0. When you plug in 1, we get 116 over 3 minus 2, which ends up being 110 over 3. So that becomes our final answer. Alrighty, let's move on to the next problem, number 9. So we got to do FDR, and then this is F. R is given to us in this way. Then in terms of F, I just have to substitute R sub t into this location, so it's not that bad. And we just have to find R prime, which is equal to 2t, and 3t squared and minus 1. Now, then f now can be rewritten as e to the z, which is e to the negative t. And then xz is multiplying this one and this one, so we get minus t cubed. And then thirdly, x plus y. So we got to add up those two. So we get t squared plus t cubed. So I gotta dot these two. Then our integral becomes 2t e to the negative t, and then minus 3 t to the 5th power. And then negative 1 is multiplied, so you get negative t squared minus t cubed dt. That goes from 0 to 1. And we don't have any issue integrating the last three. The first, actually, we have to do the by part. So I'm just going to do this one, t e to the negative t, because I'm just going to factor 2 out. Then we can say u, and then dv, du v. So u will be t, and then du becomes dt. And then e to the negative t becomes negative e to the negative t. So that's basically what we end up getting. So when we integrate antiderivative of this one becomes, I got to multiply those two things together. So negative t e to the negative t, and then integration of this one. Minus minus becomes positive, or so technically becomes plus e to the negative t dt, which becomes negative t e to the negative t minus e to the negative t. So when I multiply this expression by, technically with the plus c, but it doesn't matter for the value of c. When I multiply that by 2, I get negative 2t e to the negative t. Then minus 2 e to the negative t. And then minus t to the 6th power over 2 minus t to the third power over 3 minus t to the 4th power over 4. That goes from 0 to 1. When I plug in the 1, I get negative 2 e to the negative 1 minus 2 e to the negative 1. I can combine them together. Minus 1/2 minus 1/3 minus 1/4. Now, when I plug in 0, these three terms cancel away. So this one now becomes 0. And I have simply minus, so it becomes plus 2 from here. Then we get to realize that when I combine these three fractions, so negative, I'm going to have denominator of 12. So negative 6 over 12 minus 4 over 12 minus 3 over 12. So that becomes negative minus 13 over 12 plus 2. So we get 11 over 12 and minus 4 over e becomes our final answer. All right, with that one, I'm going to close up. I'll see you later.